The current level of network security with regard to industrial control and SCADA systems is well known to be behind the technology curve. This is due to archaic systems being used and the inability for these systems to be down for major overhauls and upgrades. In this demonstration, we will explore a concept known as a Honeynet, which allows security professionals to add to a network virtual devices which look like SCADA components, which can then be monitored for attacks. The first step in developing a SCADA Honeynet is implementing a Honeypot, or single component of a Honeynet. For this demonstration, we'll be using the open source Honeynet program. This program allows us to set up virtual hosts that can then be configured to appear as whatever operating system we desire. Upon installing Honeynet, we need to modify the Honeynet configuration file to reflect the operating system that we want our virtual host to mirror. We've chosen to go with the standard Windows XP configuration for this particular Honeypot. Within the configuration file are a few main components. We have the default instructions for our virtual machine to follow. We have the instructions on what type of virtual host we want created. And we have specific instructions regarding how we want our machine to behave, including port allowances, machine name, and lastly, what IP address we want to be assigned to our virtual host. Now that we've completed the configuration process, all we need to do is launch into Honeynet. In the command line, -D lets us see the Honeynet process rather than it work in the background. -F simply lets Honeynet know that it needs to recognize our configuration file. Honeynet has let us know that it is actively listening and ready for traffic. To test that our virtual host is operating correctly, we can ping the IP address that we assigned, and we should be able to see the echo request on our new virtual host. We can see by the responses from our virtual host that it is up and running successfully. Now that we have successfully created our honeypot, we can move on to creating our Honeynet. A Honeynet is simply a network of honeypots. In the SCADA world, having a Honeynet can be beneficial when it comes to deferring and slowing an attack on the network, while also logging our adversary's activities. We're able to analyze the attacker's methods while also keeping the activity isolated from our critical systems. In order to turn our honeypot into a Honeynet, we simply need to modify the configuration file to have multiple interfaces. The configuration file is in the same format. The only difference here is that instead of using one of the Honeynet personalities, we're using Python scripts to create our virtual hosts. Since Honeynet is open source, we have many options of virtual hosts to mimic. We'll keep it simple in this demo and create 3 protocols that we'll be able to interface with: FTP, Telnet, and HTML. Now that we've configured our file accordingly, let's test each of these out. We'll start out by launching the Honeynet command as usual. Then we'll begin our test with an FTP login request. Here we received a login prompt for what appears to be an actual programmable logic controller, or PLC, Ethernet interface. We can also see the activity engaged in our virtual host traffic. Next, we'll try connecting to our host via Telnet. This also results in a login prompt, this time from what mimics another brand of PLC Ethernet interface. Lastly, we'll try out the HTML interface. We do this by browsing to our assigned IP address, and just like that, we are presented with what will appear to our attackers to be an actual PLC web interface. While SCADA and ICS network security may not be up to date, or sometimes even existent, we can implement measures such as a SCADA Honeynet to assist us in protecting against attacks, while also helping inform ourselves and the industry on how these attacks occur.